Hello everyone. In the last video, we had finished with the medium access layer implemented in the mobile communication system. We saw the one method MACA which is implemented at a MAC layer of the mobile communication system. Now from this video, we will start with the network layer which is implemented in the mobile communication system. We know the most popular protocol of the network layer is a internet protocol, that is IP. Now in this video we will see the introduction to the mobile IP, that is IP which is used in the mobile communication system. So as you can see, the name is different. That means there must be something different from the standard IP. So what is the motivation behind developing this new mobile IP? Now we all know the primary task of the network layer is the assigning addresses to each and every node within the network and routing the packets to every node within the network. So first thing is that routing. Now how routing is done? Routing is done based on the destination address, that is IP address of the destination node, or the network prefix which is address of the particular subnet, physical subnet within which that node is residing. So if you want to transmit or send a packet to particular user, you will mention its IP address in your IP datagram, and routers will forward that packet based on that IP address or the network prefix of that particular IP address within the network. So what is the issue of routing in case of mobile communication system? Now we know that whenever we change the subnet, recall the concepts of computer network, whenever we change the subnet, our IP address will also change. For example, let's say there are two locations covered by two different networks. One network has this particular IP address, let's say this one, 129.13.42. This is the subnet prefix of this particular network. That means whatever node present inside this network, its IP address will be 129.13.42 point either 1 or from 1 towards 254. Okay, because 255 is a broadcast address, so 1 to 254 will be addresses of the different nodes within this network. So whenever you change the location or whenever a node moves from one subnet to another subnet, obviously new subnet will have a different IP address, that is, let's say 129.13.43. okay, so whenever you change the subnet, your IP address will be also changed, and that means your routing or routing of packet to this particular subnet will also change, because routing is based on the IP addresses or the network prefix of the physical subnet. Okay, so routing changes means what? The path towards destination is changed. The path towards destination is changed, and because of path is changed, the routing table entries which are maintained at the router will also change. Every subnet has a router associated with it, so this router maintains a routes towards a particular destination. Now if routes are changed, these routing table entries will also change. Okay, this concept applies to fixed network also. If you move a computer, a desktop computer, from one laboratory, for example a laboratory, from one laboratory to another laboratory, its IP address will change. So what's the difference between this concept and concept required for mobile networks? In fixed networks, this situation occurs very rarely. We rarely move one computer from one physical subnet to another physical subnet. But in mobile networks or in mobile communication system, this situation occurs very frequently. Users, most of the users are mobile, or many users are mobile, and they will frequently change their location from one cell to another cell. So every time they are changing the cell, their IP addresses will be changed, and corresponding routing table entries will have to also be changed. So what are the quick solutions for this problem? Now, changing all routing table entries to forward packets might be the right decision, but router has a responsibility of maintaining these changes in the routing table entries as quickly as possible. That means they should be as live as possible. Whenever change occurs, router should immediately change those entries. But when the users are too many, that means mobile users are too many, there will be too many routing table entry updates. Okay, so let's say if a subnet has 100 users, and out of those 100, 80 are mobile users, then changing the routes or changing the routing table entries for 80 users very quickly might not be possible for the router, and that too many times within the given period of time, because mobile users change their location too many times, and that's why it may not be possible for router to change the routing table entries quickly. Okay, but that can be another that can be a quick solution for this routing problem in the mobile systems. Then what is the other quick solution? It is quite obvious, whenever we change the network, our IP address has to be changed. So changing the IP address will solve our problems. So in mobile communication system, adjusting the host IP address depending on current location will be a quick solution. That is, from one subnet, if you are moving to the other subnet, change the IP address. But how will the sender know that a receiver has changed its IP address? Okay, suppose there is a sender A who is trying to send a packet to B. Now B has moved from one subnet to another subnet. How will sender know that its IP address is changed? So that is the question, and that is almost impossible to solve. So one solution to that may be use of DNS. All of us know what is DNS, domain name system, where a name is mapped to a IP address. For example, abcd.com is a name given to certain IP address, for example 129.13.42.10. An IP address is associated with the particular name, so that sender does not have to worry about the IP address of the particular abcd.com, and it can use abcd.com as a destination address. But changing the subnet means changing this binding of name to IP addresses, that is DNS update. Okay, because when you change the subnet, this IP address will change. That means whatever IP address which was mapped to that particular abcd.com, that will have to be also changed. So these DNS updates take too long time. Okay, so that is not also a feasible solution where DNS use will solve our problem of changing the IP addresses. Then apart from that, if you go to the upper layers, for example, we know what are the layers in the OSI layer: physical, data link, network, transport, session, presentation, which are optional, and then application. Okay, so we are talking about network layer. Now network layer assigns the IP address. Now above network layer there is a transport layer which is responsible for reliable delivery of packets, or unreliable also in case of UDP. But if we talk about TCP, reliable delivery of packets to the destination. Now TCP uses IP address plus port address for reliable delivery. Port address is related to the specific device. Okay, this IP address plus port address is known as a socket. So source socket and destination socket, that is a socket pair. source socket will remain constant because its IP is not changing. But if destination socket is changed because of change in the IP address, if IP address is changed, this socket will also change. So if destination socket is changing, then it is breaking the TCP semantics. Okay, so TCP semantics are broken in case of changing of the IP address, because that completely changes the socket, and that forces the security problems at the transport layer. Okay, because you have to confirm whether the change socket is a valid one and it is not an attacker, and there are so many other issues which are related to transport layer security. Okay, so because of this, changing the IP address is not also a feasible solution for mobile communication systems in case of routing the packets. Okay, so we can conclude that although IP is a very simple mechanism implemented at network layer to deliver the packets to appropriate nodes, it may not be feasible to implement it in the mobile communication system because of obvious reason, that is mobility of the users, and the mechanism that IP is implementing is designed by keeping fixed network in the minds. Okay, all this IP or internet protocol is designed considering only the fixed network. Mobility was never a discussion during the development of the internet protocol. So what is the solution? We have to design a new IP which will be called as mobile IP, which will be called as mobile IP, and which will support mobility, and it will allow any user to send packets to any user irrespective of whether they are mobile or fixed. Okay, so what are the requirements for this mobile IP? Now we will keep our discussion to only fourth version, that is IP version 4 of internet protocol. We know that there is IP version 6 also, but right now we will keep our discussion only to IP version 4. So what are the requirements, or what are the minimum requirements that mobile IP should have? Now first requirement is a transparency. What is the transparency? Whenever we are supporting a mobility of user, this mobility should remain invisible from higher layer protocols. Again, if you consider the higher layer protocols: physical, data link, network, transport, session, and presentation and application. Okay, as we have seen, TCP semantics have to be maintained, so mobility happening at the network layer should remain invisible to transport layer and other higher layers. Why? Because other higher layers are not concerned with what is the location of the particular user, destination user. Okay, so mobility should remain invisible means this higher layer should not notice whether a destination node is a fixed node or a mobile node. Okay, so if we have to maintain that, we have to keep the end systems, or we have to make sure that end system keep their IP addresses. So if IP address remains constant, then higher layers will not notice whether they are a fixed node or a mobile user. Okay, so we are not changing the IP address, as you can see in this particular requirement. Continuation of communication even after the interruption of link is possible. Okay, so mobile, if users are mobile, they will change their location, but they will keep their IP addresses. But while doing that, there will be slight interruption in the connection, but that connection should not be hampering the communication, that is, it should not cause a data loss. That should be kept in mind. So efficiency will be maintained, and invisibility will be also maintained. Now this efficiency should be maintained because of low bandwidth available for the wireless media. We know that wired media has very much high bandwidth available, so for low bandwidth, that is in case of wireless media, the efficiency has to be maintained. Okay, then while doing this, that is supporting the mobility, the point of connection to the fixed network can be changed. What do you mean by point of connection to the fixed network? Now this is a network, this is a mobile node, and this is the internet. Now this node is connected to internet via a router. So router connection is our point of connection. So when you change from this network to some other network, the point of connection will be changed, but it will not be observed at the higher layers. Okay, so that is the meaning of point of connection that can be changed. So that was regarding transparency. The second requirement of mobile IP is now compatibility. Now mobile IP will be developed or is developed after the standard IP. So it's a, we can call a next version. So while developing this next version, we should keep in mind that this new version will also support the older versions. Okay, so while introducing changes for the new versions, these changes should not impact changes in the application or network protocols which are already in use. Okay, that means if I am using mobile IP, I should not change my application. My same application which I am currently using in a fixed network should be able to support mobile IP as well. Okay, that this is regarding application layer. Similar regarding session layer, maybe changes, slight changes in the presentation layer. Sessions should not be modified. Presentation may be adapted for mobile users, uh, or routing protocols should also be adapted, but existing protocols should not be completely abandoned. Okay, so new version should be compatible with the older versions. Now similar to higher layer protocols, the lower layer protocols also must be considered. Okay, we know lower layer protocols of the OSI layer are physical and data. For network layer, these are the lower layer protocols. As invisibility is important for the upper layers, similarly same data link protocols and physical layer protocols should be supported by this new version of IP. Okay, we have already seen that is not quite possible in case of data link, because medium access is a part of data link, but other protocols rather apart from MAC layer should be supported by the mobile IP. Okay, and last point regarding compatibility is mobile user must be able to communicate with the fixed users also. It should not happen that mobile IP will be implemented only in the mobile users. Mobile IP should also be implemented in the fixed systems as well. So that gives worldwide connectivity to everyone. Okay, so moving on. The third requirement of mobile IP, the more severe impact of these changes in the media, that is from physical to wireless, is in the security that should be maintained while the communication is going on. So mobile IP should maintain authentication of all the messages related to communication. Now what's the meaning of this particular? Let's say a user which has changed the subnet from this one to this one. Now communicating party will not know whether user is changing its location. Now when it is changing the location, the packets which are routed to this destination now should be routed to this particular location. Now it should not happen that whenever a sender sends a packet, router transmits the packet to both the destination. When will this happen? If some attacker tries to imitate someone else's identity, let's say this is A. Now an attacker comes as, let's say, Z. This is an attacker. Now Z comes in this network and which claims to be A. Now router should authenticate this user Z that this is the same A which is changing the location. Otherwise packets will have to be delivered to an attacker rather than actual user. So security, for maintaining the security of communication, authentication should be done regarding all the messages communicated or exchanged between the communication of mobile user and the sender. Okay, so that is the another requirement. Then last requirement is a network efficiency and its scalability. Now enhancing IP or introducing new version of IP, mobile IP, must not generate too many new messages which will flood the network. So when we are changing or when we are talking about changing the mechanism of IP, something new must be introduced. Now this whatever new we are trying to introduce should not generate too many messages which will flood the network, because what will happen if too many new messages are generated, then those will be control messages, not the actual data which is exchanged between the sender and receiver. So it impacts the efficiency of the network, because network efficiency is calculated based on how much actual user data is exchanged between the sender and receiver. So that's why the too many new messages should not be flooding the network. One or two or small number of messages to mobile systems must be required, because obviously the bandwidth will be low for wireless media. And in terms of, if you have to talk about scalability, the users should be able to transit to anywhere in the world. So it should not happen that if a user in this physical subnet, it will travel up to only certain distance to another subnet. That should not happen. What should happen? This user can transmit or transit into any other location in the world, and still it will get the packet which is sent by the sender. So that is network scalability. So these are the primary four requirements of mobile IP. So we can summarize these requirements in a single sentence as: mobile IP is a mechanism which supports end system mobility. Remember, end system mobility, not the front system, that is starting system. End system mobility while maintaining scalability, efficiency, security, which is not mentioned in this statement. Maintaining scalability, efficiency, security, and compatibility in all aspects with existing applications and internet protocols. Okay, so that can be a single sentence summary of the all the requirements of mobile IP. Okay, so we have decided that new IP will be required for mobile systems. So there will be new terminologies and entities which will be introduced for mobile IP. So let's look at those new entities and terminologies. The following defines several entities and terms needed to understand mobile IP as defined in the RFC 3344. Now, what is RFC 3344? Mobile IP is developed by a standard or organization called as RFC, or a committee. It is actually RFC, which is has several versions. The version number for mobile IP is 3344, or the committee's final version of a mobile IP standard is named after 3344. So that is not an point of concern right now. RFC stands for request for comments. So users are requested to provide whatever complaints or suggestion they want or they have regarding supporting mobility. So that was standardized. Mobile IP was standardized by the RFC. So it has defined several new entities and terminologies. Let's look at them one by one. First one is mobile node. Communication will happen between at least two nodes. One of them will be a mobile node, which is a node that can change the point of connection to the network without changing its IP address. So we have seen what is point of connection to the network. Now users which are mobile will change their point of connection to the network, and while doing this they will not change their IP address. Such users will be known as mobile node. So these users will keep their IP address as long as link layer connectivity is given. So as long as data link layer is maintaining the connection, IP address will not change. Okay, so if you want to see this in terms of layers, network layer, data link layer, physical layer, as long as data link layer is maintaining the connectivity, IP will not change. Okay, mobile nodes IP will not change. If connectivity is lost at the data link layer, obviously IP will change. Okay, then second node in this part or in this communication will be correspondent node, because communication is between two or more than two nodes. The second one will be a correspondent node, which can be a fixed, that is desktop computer, or it can be a mobile node also. It can be also mobile. So communication between mobile node and mobile node can be possible, or communication between fixed node and mobile node is also possible. Communication between CN and CN, that is correspondent node, which is a fixed node, and other correspondent node is also a fixed one. If this is the case, no need of mobile IP. So fixed node to fixed node does not require mobile IP. Standard IP is sufficient for that. Then third term is a home network. Now as the name suggests, it is the subnet the MN belongs to with respect to its IP address. So if your IP address is, let's say, 129.13.42.10, then your subnet will be, for example, let's say 129.13.42. So that is your home network, because you are part of this particular subnet. So that is your home network. Within home network, you do not require mobile IP, because all the packets which are supposed to be sent to this particular IP address will be delivered to this subnet. So no need of mobile IP in this case. Okay, so remember, within home network, mobile IP support is not needed. Okay, the next term is a foreign network. The foreign network, as the name suggests, when a mobile node changes its location and visits another subnet, the new subnet is called as foreign network. Okay, because its address will be different and it should not be a same as the home network. So it should not happen that when I am changing the location, I am moving from this location to this location, because this change in location will keep my subnet same. So still mobile IP will not be required. But when you change the location from this one to some another subnet, this is your foreign network and this will be your home network. Okay, in foreign network, mobile IP support is a must, otherwise communication may not be possible. Next term is a home agent. uh, every subnet is associated with one router. In mobile networks also this will be the case. So home agent is a system in the home network of the mobile node, obviously, because its name is home agent. A home agent is typically a router which registers the location of mobile node. Every subnet is associated with one router. This router is nothing but your home agent. Okay, this router is responsible for tunneling the IP packets to the care of address COA. What's the meaning of this statement? That we will see during the uh, packet delivery, IP packet delivery. So whenever you change a location, whatever packets which are sent to you, suppose this is the node, receiver node, the packets are coming. Now this router is responsible for delivering the packets to this node, but when you change the location, how to deliver these packets? So home agent forms a tunnel and delivers these packets to the new location. Okay, so your tunnel will start here. What is the meaning of tunnel and how it is delivered, that we will see later on. Okay, so this is the meaning of tunneling the IP datagrams to the care of address. Okay, home agent could also be implemented in arbitrary node in the subnet. So it's not mandatory that home agent will be always a router. Sometimes when users are very less, let's say one or two users are in the present in the subnet, one of them can be assigned a job of a router, that is a home agent. But this is usually avoided because in the mobile networks at any given time number of users may increase, and implementing a functions of router in a mobile node is not preferable because router has too many tasks to do, and that will require high end systems, highly efficient systems. So implementing home agent in a mobile node is avoided generally, but you can do that as well if there are uh, very less number of mobile users within the subnet. Okay, so that is home agent. So if there is a home agent, there has to be a foreign agent also. Foreign agent is another router which is part of a foreign network. So foreign agent is a nothing but home agent of some different subnet. From our point of view, foreign agent is a router of a foreign network. Typically, router forwards this tunneled, whatever we have discussed, packets to the mobile node through this particular foreign agent. So, tunnel will end at a foreign agent. So, keep in mind, sorry, if this is foreign agent and this is home agent, tunnel will start at home agent and it will end at foreign agent. Okay, foreign agent is typically a default router to mobile node. It may be also implemented in the mobile node also, but that is again avoided. Then last term is a care of address. We are well familiar with this particular term in English, that is care of address. When we are living in someone else's house and we want to receive certain mails, we use care of addresses. Same thing applies to the mobile networks also, or this mobile IP also. Care of address is address of the current tunnel endpoint for the mobile node. So when you move from one subnet to another subnet, when you move from the one subnet to another subnet, you will have to your packets will have to be sent to your new address, and that address is care of address, which is the address of your tunnel endpoint, which is most probably the address of foreign agent. Okay, but as I said, mobile node can also be a foreign agent. So sometimes tunnel endpoint is at a mobile node also. So there are two types of care of addresses: foreign agent COA, that means if tunnel ends at foreign agent, it is called as foreign agent COA, or if tunnel ends at mobile node, then it is called as co-located COA, where IP is chosen by mobile node itself. Okay, that is via DHCP or some other mechanism. Okay, so care of address is your address in the foreign location or foreign network. Now in the beginning we discussed that, or we said that mobile node will keep its IP address, and now here we are talking about care of address. So if a sender wants to send a packet to the mobile node, to which address it will send the packets? Answer is quite simple. Sender does not know about the mobility of the receiver. So all the packets sent by the sender will be to the same IP address. So its IP address is maintained, but at the receiver end there will be a care of address involved which will transfer these packets to the new location. Okay, so care of address is not known to the sender, that is to be remembered. Care of address is a term of mobile IP, so sender should not worry about it. Okay, so that is the conclusion. So these are some terminologies, or most of them are discussed. So let's see the actual example network. In this particular diagram on your screen, you can see all the terms mentioned over here. CN, that is a correspondent node, present over here, which is a sender, let's say transmitter. Now it sends the packets. It is connected to a network, that means there will be a router involved. It sends a packet which travel via internet, and mobile node, which was originally should be here, so our packets are delivered to this mobile node via internet through this home agent, which is a router at the home network. You can see here home network, that means mobile node was initially in this location, now it has transferred to some other location. Okay, so packet should be given to this mobile node via this particular router, that is called as a home agent for us. But now it has changed the location to some new network, so this is called as a foreign network. Now this packet should be forwarded to this new location. How it will be forwarded, let's see in brief. To avoid confusion, I am erasing other part. So whenever packets arrive for the particular node in the foreign network, home agent will create a tunnel and forward the packets to the foreign agent, which is a router of new network, which is a foreign network. So this tunnel is formed between home agent and foreign agent. Tunnel starts here and tunnel ends here. Okay, so packets will be delivered to the mobile node via router, then wireless access point, and finally to the mobile node. Okay, so this is the general example of a network consisting of mobile IP. We have briefly seen how the packet will be delivered, but what are the issues and how exactly this packet is delivered, that we will see in detail in the next video. That's all for today. Thank you.